I'm Nik Everett. I'm a full-time contributor to Elasticsearch, and I concentrate on aggregations. Um, I plan to show you sort of how aggregations work at a low level. Um, so for that, I'm going to assume that you know how Elasticsearch kind of works, like you've used it before, and that you've written some code. You've built systems, not necessarily big ones, or I'm also not going to assume that you know how Elasticsearch works. But I'll be presenting a whole bunch of pseudocode and going through it. Um, I also should say that I'm pretty terrible at giving presentations. I'm much better at doing conversations. So please use and abuse the question feature. I love being distracted, and that will really help fill in the gaps. I'm sure I'm going to miss things as I go. But sort of the problem with this being virtual is that it's also asynchronous. So if you're seeing this asynchronously and I forget things and you have questions, I'm very, very sorry. Because I will have done this in the past. So let's talk about the sum aggregation. It's a fairly simple aggregation. On the left, I'm sticking some data into Elasticsearch, and on the right, I've got a simplification of how we implement sum. It's like a huge, huge simplification. The real implementation is like 150 lines, and this is like 20. So it's pretty much a lie. But it'll sort of get you started understanding the kinds of things that we have to do. So let me walk you through it. Elasticsearch is written in Java, so all the pseudocode that I'm going to give you is going to be sort of Java flavored. It's almost certainly not going to be valid Java syntax, and it's probably not going to be the kind of code style and all that you're used to, but that's fine. So Java being Java, there is an interface that you implement to aggregate search hits called Aggregator. And our sum aggregator, you build it up front before collecting any of the search hits, and then for every one of the hits, you call this collect method on it, and it sucks up the documents, calculates the running sum, and then at the end of the search, you call result on it, and it spits out the result of the sum. The way that we get the values for the field that you're aggregating on, this foo field, is we build this thing called a doc values, this doc values handle. Here it's called vals on this slide. And it's sort of a handle into the data structure on disk for doc values. Doc values are like a column store data structure. So if you are used to relational databases, it is essentially a single column table that you can index into very, very quickly. And you don't need to load the rest of the document. So to access the values in doc values, you call this advanced exact method. It'll return false if there are no values, and it'll return true if there are any, and then you call next value to get the next value out. This sort of funny dance with collect, advanced exact, and next value looks sort of funny, but you get used to it, and the advantage is that this ends up being a sort of linear scan on disk. It ends up loading some data, and then loading the next bit of data, and then loading the next bit of data. So you end up doing very little seeking in disks, which is very, very nice on spinning disks. And on modern hardware, it's sort of less important, but it's still a very nice thing to do because of things like the Linux page cache and read ahead and all that business. So actually, before I move on to the next slide, is everyone comfortable with that? And this is where in a small room, everyone would say yes, and I'd make eye contact with everybody. But because this is the internet and there are presently 11 people streaming this and probably 10 times that watching it asynchronously, I can't do it. So I'm just going to presume that everyone's okay, and if you're not okay, ask your question.
Let me allow people to talk. So I'll give them that ability so that they can ask questions since we are a small group.
That's awesome. Ooh, everyone's appearing.
All right, everyone has been given a virtual talking stick.
So new rules. If I ever don't make any sense, interrupt me, and we'll keep going. This is a very small group, so um, that should be okay. All right. So, like I said, this implementation that I showed you is so simple. It's basically a lie. I want to draw your attention to where my lovely pink arrow is pointing here. When you send Elasticsearch documents, it buffers them all up, and then it builds the fancy data structures that it needs, the search index, dot values, and B trees, and whatever other fun stuff that it needs every once in a while. That once in a while is called a refresh. By default, that happens every second. So if you just throw a bunch of docs inside of Elasticsearch, excuse me, it will refresh them and make them visible every second. But a lot of people change that because a second is quite fast. And if you're indexing tons and tons of data, it tends to be faster to make that every 30 seconds or a minute or something. In any case, when you're writing a test, you want to force the refresh. And so in this example I have on here, I'm forcing a refresh after I index my 5 documents. If I didn't do that, I would have immediately gone to search and may or may not gotten any results. So the fancy data structures that it builds on disk, this little packet of data structures, we call it a leaf, like on the tips of trees, right? The end bit of a tree, the leaf. And in reality, the collection is actually done once per leaf. So there is not actually a collect method. There's a method instead that gets a leaf reader. And that one is given this thing called a leaf reader context. And that is the thing that actually vends out the doc values accessors. So in this case, we have 3 leaves because we call refresh 3 times on the left. And so one of those, we'll end up building 3 of these leaf collectors. That method shouldn't be void. There are a lot of typos on this, but it's okay. We'll end up building 3 of these leaf collectors and call them once for every document. So the sum aggregation's job was to sum up a bunch of values, right? It's fairly simple. The data histogram aggregation's job is to split the documents into groups and then fire the documents into the children based on the group. So if you, like in this example, ask to group by days, the date histogram will look up on that timestamp and see for the first 2 documents, it'll group them together, and then it'll fire them into the sum aggregation together. And then the next 3 it'll fire in together. And the way that it does this is that it resolves those groupings to an ordinal, basically just an integer, long, like a 64-bit integer. And then when it calls collect on the sum, it passes down the grouping ordinal, which on this slide is called child ord. You'll see here that the leaf collector method and its collect method sort of rhymes with the sum aggregation method. It does the same thing where it does advanced exact and bails if there are no values, and then fetches values. In this case, it rounds the values. I've omitted the actual implementation of round. If you are interested, bother me later. I've sunk months of my life into the implementation of that hidden round method. It's fun, but it's also expansive. Anyway, after it rounds the values, it uses a hash table to look up the child ordinal based on the rounded value, and then it fires that child ordinal in. So whenever it gets a new rounded value, the hash table vends it a new counted value. So the first day, August 20th, when I wrote these slides, that would get the ordinal 0, and then the 21st would get the ordinal 1. So like I said, these are all the when I presented the sum aggregation, I did not have that part of the interface declared. So now I'm going to jump back to the sum aggregation and show you how the sum aggregation handles it. In the old slides, that return used to just take a doc ID. Used to return a method that just took a doc ID. The collector used to just take a doc ID. And in reality, it actually takes the ordinal of the grouping that it needs to collect and the doc ID. So this slide is actually a heck of a lot closer. It's not the 150 lines that the sum implementation really is, but it is sort of recognizable as basically how the sum works. The interesting bit is instead of keeping a single double values sitting around for the sum, we keep an array of them, and we grow that array as we get more and more ordinals, as we see more ordinals. And then when you fetch the results, you just tell it the ordinal of the result you want to fetch, and it yanks it out of the array and is all done. So, like this charming man, you may ask, why do you go to all that trouble? You could just have one aggregator instance per bucket, just like I did in the first slide, well, second slide, and just hash to the object instead of the ordinal. And that's super reasonable if you're collecting like thousands of buckets and you have millions of hits. But we're shooting for collecting millions of buckets across billions of hits. Because folks can really do crazy aggregations, right? If you put your sum inside of a date range, you probably aren't going to have millions of buckets, right? Even if you aggregate down to the minute across a whole year, there are not millions of minutes in a year. There are many thousands of minutes, right? I hope I'm not wrong. I haven't done the math in a while. Anyway, someone correct me if there are millions of minutes in a year. But anyway, people can make deeply nested structures of aggregations. So it is quite possible to nest terms aggregations inside of the date histogram, and then terms aggregations inside of that again, and the whole thing can explode quite a bit. So we try to be as compact as we can when representing these aggregations when we collect them. And then when we go to actually return the results, we allow ourselves quite a bit more object-oriented, space-takey-uppiness, because we tend to collect far fewer of the aggregations than we aggregate on. One day, maybe, we will not do that and we'll be more compact. But as it is now, we sort of have to collect fewer, like we have to collect thousands of results, not millions of results, just because we shift objects. Anyway, the solution that we have where we build one aggregator per, like where we build one sum aggregator and that can aggregate millions of buckets, that solution costs about 32 bytes per bucket. Which is great. I mean, that's about as good as you can get. Allocating a new aggregator would cost somewhere in the neighborhood of a couple hundred bytes per bucket, maybe 100 bytes per bucket if you're lucky. But once you start to try and save enough space and allocate like merge things together, you end up looking just like the implementation that we have, where we have a single thing. And like I said, hundreds of bytes per bucket isn't bad, but when you are collecting millions of buckets, that starts to add up, right? That's many megabytes of memory being sucked up by your aggregation. You'd prefer not to do that. So let me show you the implementation of this grow method. It actually oversizes the array that it's growing to. So it sort of amortizes to not allocating for every new bucket. Basically, it divides by 8, takes the minimum of the new target size divided by 8 and 3. So it will grow by at least 3 or the target size divided by 8. And then it allocates a new array. And as that array gets bigger and bigger, that sort of smooths out to it allocating very rarely. It's also worth looking at that doc values handle that I told you about. So like I said, there's this handle for this on disk column store for doc values. It's not really clear how much memory that handle takes up, because there are a zillion different implementations of doc values. Some of these implementations take up almost no memory, like as little memory as a Java object can take, 32 bytes sort of size, 64 bytes sort of size. Other doc values implementations take up many kilobytes of memory because they end up spooling things off of disk. The leaf reader context, it sort of assumes that you're going to be fairly frugal about how you access doc values. You're only going to access the doc values that you need, and you're not going to access the same doc values multiple ways, and that sort of thing. So the leaf reader context doesn't have any incentive to try to save a ton of space. So we try to save the space when we do our own aggregations. And finally, look at this hash table in the date histogram aggregator. If we ended up having to have a hash table per date histogram, so imagine a date histogram being contained in a terms aggregation, or maybe another date histogram aggregation. So if we had to make a new date histogram for every bucket, we'd have to make a new hash table for every bucket. And, well, the whole point of having a hash table is that it can allocate smoothly if you build a big one. But if you build many small ones, you end up having to allocate over and over again. Also, the hash table can pick a fairly interesting implementation. It can be aware that it only is ever going to be called with a single owning ordinal, or sometimes it isn't. Like it can be aware of how it is being called. So we can make sort of intelligent decisions about which hash table to use there. And we can only do that if we build a single aggregator per level. So that is why we do it. And that pretty much is the end. I'm really hoping for questions because, like I said, I'm sure I forgot things. I'm sure there's a zillion things I didn't cover. For example, I didn't cover at all how we reduce aggregations. Please be typing your questions now while I'm filling the airspace. I am giving you time to type. One thing I didn't cover was how we reduce the aggregations together. All I showed you was how we aggregate on a single data node. And you'll know that Elasticsearch can shard its indexes, and you can aggregate over a zillion indexes and pull them back together. You can even aggregate over indexes that are geographically distant from you with cross-cluster search. And we have to be able to merge together the results from all these aggregations. For like some, it's as simple as adding them together, but for other ones, it can be more complex, right? How you deal with filling in the holes in like the date histogram aggregation and things. But that is a topic for another time.
Hey, Nick.
Hey,
thank you
ask.
for sharing your knowledge there. I had a question. I initially came across aggregations on accident when I was trying to find out how to run an Elasticsearch in a given date range, and learned that aggregations are the better way to do it instead of a search filter. But I was wondering if you could give just kind of like a brief overview of the differences between the two, like different use cases when you would want to use a filter versus an aggregation, and maybe like performance trade-offs between the two.
Yeah, so that is a very different layer than what I was talking about before. But I can certainly
Yeah,
talk
sorry,
about it.
more high level.
Yeah, at a high level, generally you want to use aggregations anytime that you thought to yourself, I wish I could pull back all of my documents and do some math on them and then get an answer. So anytime you want to look at a huge number of documents and boil them into a certain bit of data, a search that does not have an aggregation, whether it has a filter, queries, or whatever, it only looks at so many documents. And our searches really try to only look at the 10,000 or so top scoring documents. So if there's any sort on your results, or if there's any score on your queries, we try to stop the search as fast as we can and immediately give you the 10,000 highest scoring documents. So we don't do any sort of cross document looking outside of aggregations. So aggregations, the job of an aggregation is to summarize a bunch of documents all together. It's the only tool that our search has that does that, or that Elasticsearch has that does that. Regular search just pulls back the top hits, which really just shows you stuff about a single document. So it isn't clear from the problem that you had, right? You were talking about filtering. It's not always clear that an aggregation is the thing you should look for. For example, it's fairly common for people to write an aggregation where they want to find data in a certain range, right? Where they search across, I don't know, a day or two, right? And they want to group in that date range. Well, if you don't also have a filter that limits the documents that are sent back to the aggregation, you can end up getting sort of a wide range of things. So if you use like the date range aggregation or the range aggregation, and you specify some ranges, the aggregator implementation that I showed you, this guy, we're going to call this method, this collect method, once per document that the search gets. So this is sort of another thing that's very different about aggregations versus the rest of search. Everything else tries to do no work for documents that don't get returned. It tries to look at the score of the document or look at the sort of the document and entirely skip it. Right, so we're able to use, in a regular search with scores, we're able to use the fancy data structures on disk, the skip lists, and the data structures that we have for storage and indexing to not look at documents at all that don't match your search. And that is how aggregations work, but or rather aggregations can be filtered that way. But if you don't filter them, they receive all the documents. And so if you put like range clauses inside of your aggregations, the aggregation will still see the range, right? It'll still see all the documents and it'll go check which range is this in. Anyway, I've sort of wandered away from your question, I think.
Excellent. Thank you. That really helped clear it up. I didn't even know that part, that the search is just looking at the top hits. It's not looking at the whole data.
Well, it does look at the whole data, but only insofar as it can get you the top hits, right? So without an aggregation, if you don't put an aggregation into your search, the search will terminate as soon as it has all the top hits. As soon as it can be sure that there are no hits further down that will end up in the top hits. And whether it can do that because the index is sorted and you're returning from and you're doing a sorted search, or whether it can do that by refining the queries and the scores that you have, it'll stop, right? And that's good. That's what you want, right? Because from top hits, you want the answers as fast as you can. But aggregations need to see all the hits because they're for summarizing.
Thanks for clearing that up. That really helped.
Awesome. If there are any more questions, please ask them, or we'll switch to Jeff and you can ask at the end too. That'll work. All right, Jeff, I will stop sharing. I have stopped
Great presentation.
Sharing. Thank you. Go ahead.
All right. Can you see that?
Yep.
I can see it.
Okay. So, ES in action, or how I build a CLI tool to interact with Elasticsearch. That's the name of my talk. I am Jeff Moore, and I am a systems engineer at Bandwidth on what we call the platform team. So my team, to give a little bit of context, is responsible for delivering kind of a platform to the company. So part of our objective is to say, hey, what do our users need, and kind of build up the tools we have around that. So part of YesCuddle was kind of trying to work towards that. So this presentation can go a number of ways. It is definitely a lot more than a 30-minute slot can support. But the beauty of it is I got to kind of optimize towards the audience. And my audience, I'm assuming tonight, is operations versus developers. And I'll kind of go into that a little bit more. But for the development side of the house, if you want me to go into code towards the end, let me know and I can, or maybe that's another talk. Feel free to stop me at most any point so we can discuss maybe some of the finer details of the utility. But suggestions are kind of encouraged to be until the end. And the caveat to that is there is a little bit of a video or a very long GIF. So I'd prefer not to be interrupted by that because I can't really pause it. So YesCuddle has existed for a while and contributors are welcome. I thought I'd put that first and foremost. Use it, find bugs, tell me it's great. Any feedback is welcome. Some of the things I hope you take away is a CLI tool that is useful to both yourself and the companies you work for, or even if you're independent, that you can use to kind of work with Elasticsearch clusters, and kind of some of the lessons I learned from a year of developing in Golang. So a few caveats. This is not complete, and it is very far from complete. A lot of the work has been focused on getting good boilerplate so that it could get completed faster. Not all endpoints have been implemented. Elasticsearch has a lot more endpoints that I care to imagine, and those all haven't been implemented. The boilerplate kind of took away from the code generation efforts, which I'll kind of touch on at the end. But there is still a lot of work to do. And kind of most importantly, this isn't meant to replace SDKs. There's a range of tools that are used for any kind of application. SDKs are kind of on the lower level for connecting directly to it. This isn't meant to replace that. SDKs will always be a better programmatic way to interact with the cluster, but for people who manage this at an administrative level, I feel like this is a good tool without having to also learn how to make good code. So why YesCuddle? As I said, devs have a lot of SDKs. Looking at the Elasticsearch repos, I think I saw 4 or 5. Amongst them are Java, Golang, and Python, but I didn't really see any tools that help with the operations side of the house. So YesCuddle kind of was useful for myself and my team, being responsible for the Elastic Stack, or the various Elastic Stacks we have internally. So we needed an easier way to interact with Elasticsearch as operators of the cluster. Today, I believe we have 3 clusters that we manage, but there are around 6 or 7 around the org. In 2019, we started working with Elastic Cloud on Kubernetes and started offering that to our internal customers, our users. So with that, a lot more clusters started popping up, or we needed to at least scale to that demand. And part of that is having a programmatic way to interact with Elasticsearch clusters and move between them. And Kibana is wonderful, and it's a great tool, and I highly recommend it, but it's just not suited for that kind of operation, interacting with a bunch of things a bunch of different clusters at the same time. I don't believe that would work without further orchestration. So a command line utility seemed like the best bet. So with this in mind, the intent was to take the standard endpoints that Elasticsearch has and copy those and translate those into commands with basic config options necessary for the function of those endpoints exposed as flags. And what this means, for those of you familiar with Elasticsearch, there are cat endpoints /_cat. So /_cat /nodes would be implemented at YesCuddle cat nodes. So stuff like that. And then I would also sprinkle in a few extra commands that are really useful. I'll show you one a little bit later. But that's kind of the intent for YesCuddle. And now moving on to the inspiration. I may have failed to mention this, but I'm a huge fan of Kubernetes. Kubernetes is probably, I think my top two favorite softwares right now are Kubernetes and Elasticstack. I'm not quite sure which one is my favorite because they're both amazing in their own ways. So I see a lot of similarities in Kubernetes and the Elasticstack, especially Elasticsearch. I'm not arguing that they're the same thing, but I would like to say that they are similar. Kubernetes focuses on the compute side and Elasticsearch focuses more on the storage side, but not from like a data storage, but like a document storage. So I do see a lot of similarities in that. Now, this logo you see here, that is the logo for kubectl. And for those of you familiar with Kubernetes, that is the go-to tool for interacting with Kubernetes clusters, other than Helm or Ansible or stuff like that. But from a command line perspective, kubectl is the go-to utility, and it is amazing. It is absolutely amazing what this small binary of a few tens of megabytes can do. So that was kind of my inspiration. I wanted something that almost had feature parity to kubectl and could interact with the cluster in the same ways. And here's a little bit of why. So for each command in kubectl, there's a usage, there are arguments, there are flags, there's a lot of stuff we can do. And immediately upon seeing this around a year and a half ago, I knew that the same thing could be a vision for Elasticsearch. So like you have kubectl create, kubectl get, kubectl run, kubectl expose, kubectl delete. Now the layout of the application of the commands for Elasticsearch are a little bit different, which I'll get into, but it's still the same idea. You have a command line utility that can mock the different APIs that exist. And digging into one of these commands, you also have subcommands. So for some of these commands, you can perform, you have nested endpoints. You can do like kubectl rollout and then an object after that. So that's a really easy way to interact with things without having to memorize the exact API calls for every single endpoint as an end user or an operator of the cluster. So one of these subcommands is history. So kubectl rollout history, it's really cool. It shows you the arguments, and you have a list of flags that you can use to kind of modify what would be the payload before sending it. And I'm not sure about you, but I think that's absolutely amazing. And that is why I have this vision for ESCuttle, and that's where it comes from, and that's where I want it to be, including the documentation, which is, I believe this is automatically generated. So that's definitely on the roadmap for me. And I knew this had to be building ESCuttle. Kubectl is written in Go, which is why Kubernetes is written in Go, which is why I originally started writing Go so that I could extend Kubernetes. Kubectl is also written in Go, to my knowledge. So ESCuttle, by extension, would have to be written in Go. Otherwise, it'd bother me forever. But at the time, about a year ago, I wasn't a very strong Go developer. I wouldn't say I'm a strong Go developer today, but I'm definitely a lot stronger than I was as a Go developer now than I was then. So on my team, one of my peers decided to write something called ESCLI. And ESCLI is written in Bash, and its intent was to do the same thing as ESCuttle, but to do it quickly. And as a Bash utility, it could obviously get out a lot faster than a Golang utility, especially with the barrier to entry of Golang. So here are a few metrics between ESCLI and ESCuttle. So all functions are Bash functions. There are no subcommands. So every function is, so in ESCLI you have in ESCuttle you have ESCuttle cat nodes, but for the Bash function it would be ESCLI underscore cat nodes, or sorry, ESCLI underscore cat underscore nodes. There's a little bit of a difference there. The number of commands in ESCLI is a lot higher than ESCuttle, and that's intentional. ESCLI is definitely very operator focused. I don't go over the functions in this talk, but you should definitely check it out. I'll add a link to this slide deck at the end, or I'll send it out. But it has a bunch of tasks that are routinely performed by operators of the cluster, while ESCuttle originally, based on the boilerplate I was making, made it easier to mock the actual endpoints. So as it stands today, ESCLI is likely a little bit more complete as an administrative tool. But ESCuttle has a potential with the continuous refactors and the extensibility. Like I said, ESCLI functions are easy to add as bash. ESCuttle, it's tedious. There's a lot of different pieces moving around, but once you understand it, I could say it is a little bit easier. And there are a few other metrics here that kind of reflect what I've been saying. So enough about ESCuttle. I want to show this thing off, so I'm gonna do a demo. So first, I'm going to give you an overview of my demo environment. Then I'm going to give you an overview of a local cluster init script. In this demo, I have two clusters that I work with, one that is running via Podman on my laptop, and one that is running on my home lab architecture. So I'm going to give you an overview of the local cluster init script, the Kubernetes manifest necessary to deploy the Elasticsearch cluster on my home lab, and then I'm going to give you a demo of some commands and features. So my home lab architecture, it's a little bit more complicated than this, but this is the simplest I could make it in the time I had. My laptop uses WireGuard to connect to a Google Cloud compute instance that is a WireGuard server. A jump box within my network also runs WireGuard, so that is how the connection is complete. And then from that jump box, I can access my K3s cluster made by Rancher, where I run Elastic Cloud on Kubernetes, which is amazing. This isn't the ECK or Elastic Cloud on Kubernetes talk, but that is an amazing product, and the recent 1.2 release makes it even better. And on ECK, using that ECK operator, I provision my Elasticsearch clusters. So getting into the demo. So let's see. I'm going to have to replay this. 1 second. I'm going to exit out of this real quick so I can replay this. Sorry about that. I'm going to figure this out real quick. It shouldn't take me more than a minute.
I'll stall for time.
Are there any questions so far?
Oh, perfect.
Okay.
We'll say that in my previous life, I've done some Kubernetes work, and the amount of just learning I had to do to get up to speed to get started was intense, right? There's a zillion tools, Helm, Terraform, Kubernetes, Docker, and they all sort of jump on you all at the same time if you want to do anything. And once you get it, it was amazing. It was like eye-opening, like, oh, Kubernetes automatically does all of the things that you should do when you're deploying software. It was really exciting and happy and wonderful. As eye-opening as when I found Ant and Ivy and Maven years ago. As sort of terrible and old as those tools are now, they were eye-opening and amazing 10 years ago, 15 years ago. Kubernetes is like that now. Or at least was when I first learned it.
Let's see. Okay, I believe we're good to go. So there was a little bit of I had an overview of commands here, but they were not very important. Right now, we're going over the config, this bash script that I used to initialize the Podman container. So from this, I expose 9200 on my host, and I run Elasticsearch 9.0. An overview of the Kubernetes manifest. So I have a namespace called ESDemo. I have a 7.9.0 Elasticsearch cluster. It has the self-signed certificate, uses subject alternative names. The one I use is esdemo.apps.tr1.ephemeralsucks.co. It has a node set, which is just a configuration for a set of nodes. So I run 3 nodes. They are master data and ingest nodes. And that's the first part of the manifest. It's really cool because Elastic Cloud on Kubernetes allows you to provision resources the same way you provision normal Kubernetes resources. So before ECK, a pattern was to maybe just deploy a pod with Elasticsearch on it and orchestrate the lifecycle of those Elasticsearch pods yourself. But with ECK, it becomes seamless. So moving on to the rest of this, there's a volume claim template at the bottom here. And that just says that this has 5 gigs of storage. I don't really need much for how small my infrastructure is. So moving into this, I'm just running through the commands here. The first thing I'm going to do is escuttle --version to verify what version of escuttle I'm running. Escuttle version 0.1.4 was released yesterday with a lot of improvements on the config subcommands. Next, I'm going to verify that port 9200 isn't running. So I'm verifying that I'm not cheating and running a local Elasticsearch cluster without the script I alluded to a little bit earlier. So this is going to start the container, expose the port. This tool /run elastic container.sh was really helpful early on before I could get a really stable infrastructure for running Elasticsearch. So it's really awesome to have Docker containers that can do that stuff. As we can see now, we do have that running on port 9200 on the host, so we can reasonably assume that this cluster is, or this Elasticsearch cluster is working as intended, but we're going to go a step further and verify that with esconfig. So with escuttle, I specify a path to config file. The subcommand is config, and I generate a default config. So what this does is it generates a file similar to a kube config with a context, a user, and a cluster. Creates it if it doesn't exist, and then it does verification that it can connect to it in the background. So next command is escuttle Git Cluster Info. So now that we have a context defined and we have a config, I use this command to verify just the cluster info. So cluster name is Docker cluster. Cluster UID is that really long UID that I can't read. But as we saw in the definition for tool /run elastic container.sh, this is a 7.9.0 cluster. And then I'm going to go on to check the cluster health, and it is green because it has no shards. And we can also see that it has 1 data node. So we know that this is the right cluster based on the context we had before. For each of these commands, it's cool. Based on what I use on the background, you get help commands for each command if you don't have the number of arguments that you need. And moving down a little bit, we cat nodes. So hopefully you're starting to see a pattern of becoming a little bit easier to work with from the API, or than the API directly. Kibana's DevTools is amazing, but building out all those commands can get a little bit tedious, especially if you kind of know what you need, but you don't exactly know what you need. So next command, escuttle cat nodes OJSON. Those of you familiar with kubectl are very familiar with this -o flag. So for all of escuttle, or most of escuttle, it's a little bit deterministic. You can specify your output format in either a JSON, YAML, or the default is tabular. So that's really cool if you want to maybe extend this by taking this and feeding it to other programs. So that's also a possibility. And another similar to kube configs, I'm going to list the contexts that exist. And this gen default config command gives you 2 contexts, local and elastic at local. I use a little bit of interesting naming convention here in that I do user at cluster unless you specify different connection options. So now I'm working on adding the remote cluster. This is necessary because I separate my clusters by kube configs for sanity purposes. This name is used in a few different places just to build out other stuff. And here I'm verifying that this cluster doesn't exist. So kubectl get Elasticsearch in the namespace, no resources found. So that means that Elasticsearch cluster doesn't exist. I'm applying the manifest, which creates the namespace and the Elasticsearch cluster. Reminder that this is on Elastic Cloud on Kubernetes, and it's fairly seamless. I could create one of these. I could create 5 of these. It'd basically take the same amount of time. And that's what's amazing about Elastic Cloud on Kubernetes. But this is not Elastic Cloud on Kubernetes talk. Still amazing though. So looking at this Elasticsearch cluster, we can see kubectl get Elasticsearch in ESDemo, just namespace. We see that Elasticsearch cluster does exist. It takes a little bit while to initialize its health, but that's all right. Is the bottom cut off or is it hidden?
I
Out of
see
curiosity.
Elasticsearch health unknown 7.9 applying changes 30 seconds.
Okay, just want to make sure. And moving down a little bit further, so for my infrastructure, I have to provision the service as a load balancer. I didn't call this out in the Kubernetes manifests, but based on my infrastructure, I have to expose a port on my nodes as kind of like a node port. So I do have access to the service. I just have to get to it in a non-standard way. And this, I get the port. This is kind of a standard way to get the port for Kubernetes, for Elasticsearch clusters provision on Kubernetes. The cluster name -es-http is a service that is provisioned that you can connect to, and it is load balanced since it's on Kubernetes. So that's kind of an easy win for you for running your Elasticsearch clusters. You don't have to worry about setting up like a load balancer in front of it because Kubernetes does that for you. Next, I have a static FQDN. As I pointed out in the Kubernetes manifest, there's SANs provisioned for my cluster so that I can get a little bit closer to certificate security. So I use that SAN to connect to it so Elasticsearch doesn't return some errors. In the future, I plan to maybe add a legitimate certificate to like Let's Encrypt or something, but for now, that's just what I do. And the next thing I do is I get the password. This is fairly elaborate, but to my knowledge, there's no other way to get the default credentials that you need to connect to Elasticsearch. So what I'm doing is I'm getting the default user that's provisioned Elastic, which is a randomly generated password. I'm decoding that from Kubernetes because Kubernetes returns base 64 for stuff like that in secrets. And I'm using that to generate a context, as you'll see a little bit later. So this is probably the most powerful command to get you started in esctl, and that's kind of why I have such a long pause here. So esctl config context gen, the name of your context. There are a lot of different ways to connect to an Elasticsearch cluster. There's exhaustive lists from what I know. There is, for credentials, is user, password, API key, token, and there's probably something else I'm forgetting. But there's a lot of different ways to connect to it. And for the address space, like what you connect to, there's addresses in Cloud ID. And then you can also choose whether you want to connect to it or whether you want to accept non-verified certificates or not. So there's a lot in connecting to an Elasticsearch cluster, and esctl config context gen or generate, because I have an alias on that specific subcommand, will allow you to connect to your Elasticsearch clusters really easily, as you'll see. If I didn't have this insecure flag, I could not connect to it. It would fail a test that it has internally to make sure you could, but before you provision a context, kind of jumping around a bit, it verifies that you can connect to that cluster successfully. And it does Git Cluster Info equivalent before it actually writes the config or writes the context to the config. I have this static definition for the context here because reasons. And then next, I list the context to verify that I have an additional context. Before we had local and elastic at local. Now we also have elastic at demo. Oh, and I forgot to mention that every command can have a context, as we see here. I'm running the same Git cluster info that we had before, but this time I'm telling it which context to choose instead of the currently selected context. Kubernetes and kubectl users will be very familiar with this. And we can see here that we have a different name, we have a different cluster name, we have a different cluster UUID. Version's the same because I wanted it to be the same. So this is a different cluster based on the information we have now. And in the next command, we're gonna use yesctl config context to use. I'll get into why that syntax is that way a little bit later. But what this does is it's a little bit easier than the way that Kubernetes handles context. But what it does is it sets the current context. And it validates the current context before you use the current context. So for the next commands, we don't have to worry about providing a context flag. So if we do yesctl config, yesctl get cluster health, we see that this is 3 nodes. It's also green because it has no shards. We have 3 data nodes. And that's about it for that command. So hopefully you're continuing to see this pattern of maybe interacting with these clusters a little bit easier. So here I did a git nodes in the YAML format. I don't think a lot of people know about the YAML format for output. I think you specify the content type header, but that's abstracted away by the backend SDK that I use. YAML isn't always appropriate for output, but it does exist and sometimes it's useful. Maybe if you want to write it out to a file. It's definitely a little bit more human readable in cases. There's also CBOR and Smile. They're also supported by some Elasticsearch APIs, but I don't think they're implemented in the SDK I use. I don't think they're used enough to justify it. So yeah, that's a demo. I ran a few commands. I showed you how to initialize a default cluster or initialize a default config. I showed you how to connect to a new cluster by generating a new context on that config, how to switch context, a few basic commands. And like I said, yesctl, it's kind of self-documenting in that if you specify a command without all the necessary arguments, it gives you the help for that command. So that can be very powerful there. Now, moving on a little bit, or actually, before I move on, are there any questions so far? All right, I'll take that as a no. So command structure. You may have seen if you were paying attention to the command structure, which it's a very, very specific thing, but it's different than the Kubernetes format, and that's intentional. So in an ESCtl example, you have ESCtl endpoint or resource function, and in kubectl it is kubectl function resource. And here's a little bit of a comparison there. So in kubectl, to get the nodes that are on a cluster, you run kubectl get nodes. And ESCtl, you run ESCtl cat nodes or ESCtl nodes list. It's backwards, but that's the way the APIs are laid out. So that's the way I kind of mocked it. I wanted it to be as close to the API as possible in most cases for the basic stuff. So I took that design approach, and I'm thinking about refactoring it, but I'm not sure if that's the best approach. I'm still undecided. So in another example, where things kind of get weird, the gits on Kubernetes are the same. So you do kubectl git namespace, kubectl git nodes, kubectl git services, but esctl, the endpoint or what you're targeting is always the second or is always the first argument. So it's always esctl index git or esctl machine learning jobs git or esctl index or esctl watcher git. So that's just how it's laid out. So there is a little bit of inconsistency in itself, and sometimes the abstractions leak from what I'm trying to achieve with this function. I'm not even sure if I can call it a function or this endpoint and then function. Sometimes the abstractions leaks out a bit. I noticed that in my git commands, git cluster health should be cluster health git, but I made those decisions. I implemented those functions early on, and I'm going to try to stick to that abstraction as it exists, as I kind of want it to exist. So the endpoint behind commands like esctl cat nodes is, like I said, _cat/nodes. By mocking functions after their API syntax, there's no mental translation tags to move to and from esctl and the REST API. Ideally, this isn't ever intended to be a crutch. And so I wanted to keep this as close to the API as possible. So you don't have to worry about translating esctl git nodes to an API call in the future. You can know that esctl commands always mock the API where available. So for a little bit of the back end, I'm not going to touch very much on this, but it's there are a lot of Elasticsearch SDKs. This one is the Go SDK written by I'm not sure how to pronounce his name, but he's from Elastic, and I've worked with him on a few different issues that I've raised against the SDK. What it does is it defines the API endpoints as structs, and then allows you to initialize clients. And what esctl does is it works with those struct fields, adds to them by converting the flags to struct fields. And there's the repo for go-elasticsearch. I highly recommend it. It's amazing. I use it more and more every day. So it's really cool about esctl. I don't show this in this demo, but it's mostly boilerplate. As I've probably said like 2 or 3 times now, a lot of the effort has been focused on making good boilerplate, because boilerplate means the functions are less complex. And if your boilerplate is shared amongst probably hundreds of functions when this thing is done, then the time spent optimizing the boilerplate is also offloaded by the gains that you get from writing easier functions. So that's one of the beauties of it. And even if and it's extendable as well. Here I'm going to go over a few problems that I can solve with esctl. Like I said, I'm probably not going to go into the code unless you really want me to. The code implementing a function typically takes anywhere from half an hour to maybe 4 hours. But these problems or these examples I'm going to go through are mostly solved. They just need to be implemented with the current boilerplate. So showing inactive watchers. So those of you familiar with the watcher APIs know that you can get the .watches index, and it will show you in the reply, and I probably should have had a little bit of JSON here, but in the reply, it'll show you a field that tells you whether or not it's inactive or not. As an operator of the cluster, I want to filter on watchers that are inactive or active. So that's a practical example that I added, and that's in I believe it's esctl watcher show inactive and esctl watcher show active. So you kind of use esctl to kind of get most of the way there with the search, add a filter, and then parse that output from that filter from your original data set. And that's a really cool use case here. So first, I would use a search request, which comes from the SDK. I would filter that with a desired activity state. That's an ESCuttle bit. I have a function called reduce watchers to, which takes a bool, and I believe it takes a struct that is the output of the REST call, of a successful REST call, and it just filters on that. It kind of, like if I wanted only the inactive ones, it would check for active equals false, and then it would just return the data set that had active equals false. And then I just return the output, which I created something called ESUtil to kind of help with the stuff that all the functions that all the other functions share. And that's part of the reason why I have the output formats that I have. So that's a really simple one, and that one already exists. Feel free to look through that one. Another one, this one's a little bit more complicated, but it has a really cool story behind it. Sometimes our users have to delete data from Elasticstack, and that's cool, but deletes are a little expensive. At least myself and my team haven't really figured out a great way to optimize our queries to run a little bit faster or make them less expensive. So usually it is much easier for a user who knows their data set to make a query and then give that to us. But it isn't good enough for a user to take their query, us to run a delete by query, and then delete documents. We also have to do a little bit of validation as good stewards of the cluster so that we don't impact the other tenants of the cluster. So my idea for this one, and it has yet to be implemented, but at a high level, I've already have this solved. You take a query, which in Elasticsearch is just in the JSON body, you would have the query, you'd have a query object in JSON. You take that, and then you take a known aggregation key with a set of aggregations. You merge those two together, and then you make a new search. So that gives you is the ability to define different metrics that you want to search on. So if a user says, hey, I want to delete documents from this site, or this query should impact documents from this site at this time, your query would be able to validate that. It isn't necessarily, wasn't intended in the ESCuttle implementation, this isn't intended to validate, but mostly to visualize. So this would probably end up going in the administrative set of packages, which is kind of where ESCLI aligns today. So the part that's kind of eluding me today is the merging of the JSON objects. I know there are Golang packages that can help with that, but once we had that merge, we just execute the query, and you could literally just return the output, and we could maybe even run a filter path on that output to just return the aggregation pieces. So that's a really easy, well, it's a very simple reduction of a somewhat complicated problem, all because it's in Golang and using kind of the ESCuttle framework. Obviously the Elasticsearch SDK underneath it. So last example, this is one that came up pretty recently. We have a lot of indices created by ILM policies, and sometimes those indices aren't used because users they have a little bit of freedom to write to whatever indexes they choose based on a retention policy. And so if users aren't using a specific retention policy, those indices are still being created, but they're empty. And that's caused a little bit of imbalance on the cluster due to the shards being equal, but sometimes you have a concentration of shards with no documents on a specific node, which then causes a higher concentration of larger shards on other nodes. And so it's determined that pruning the empty indices would be a good way to get around that, so that you're guaranteed that you have larger shards when you have a shard on a node, since shard count is the only thing that Elasticsearch balances on today. So all I would need to do there is a get indices or indices get request, which get a list of indices. I can apply the same filtering logic, although it looks a little bit different, as I did for the watcher example, to filter to indices containing 0 documents. I could take that, convert it to a list. I could run strings.join with a comma, because you can have comma delimited indices in Elasticsearch, and I send a delete request with that index, I suppose I can call it an index pattern of those comma delimited indices, and now I resolve this problem on my cluster. And all in all, this is probably the easiest solution out of all three that that there is to implement. If you're still not sold on using ESCuddle, which there are reasons, it's still, like I said, it's not complete. All the endpoints aren't mocked. But what if there was a generic way to build your own HTTP calls or REST calls that was already built in? Maybe that would help. Well, I have a solution for that. It is ESCuddle API. And what ESCuddle API does is it takes a HTTP verb and it takes an endpoint and a list of headers, or sorry, not a list of headers, a set of flags that you can use to modify that a little bit, and allows you to make whatever API call you want. So if you want to call cat nodes, as I've used an example a few times during this talk, you could do ESCuddle API get /_cat/_nodes, and there you have it. You have a generic way to interact with the API that is fairly easy to use based on config files and context and stuff like that. So if you needed to make a quick API call, rather than logging into Kibana, you could use ESCuddle to kind of get those quick and dirty commands to see what the cluster's doing. I learned a few lessons writing this. The first is writing a CLI tool isn't easy, and I don't think it's supposed to be. You really have to understand the product that you're working with, that you're designing around before you start writing it. So with that in mind, I probably should have spent a little bit more time designing the code, so I didn't have to refactor as much. Most of my time has probably been spent refactoring. ESCuddle has come a long way, and I'm surprised at how many refactors I've been able to do. But design, taking some of those programming lessons that people have learned over the decades, like design, I learned about functional design patterns in Go the other day. It was amazing, and I was like, huh, my code does this a little bit. Why didn't I do this sooner? Just knowing that would have saved me a lot of time and made a lot better code overall. Another thing is reading documentation before writing code. I have a bad habit of wanting to write code and kind of get lost in it, when really sometimes reading through documentation thoroughly to see what options exist and what kind of edge cases you need to account for is more important early on. And the most important lesson is that this CLI tool continues to be a great learning opportunity for me. There was a problem of interacting with Elasticsearch clusters at work, interacting with a lot of them at the same time in a scalable way. And this CLI tool was kind of a way to not only fix that problem, but also to learn more about Elasticsearch and the Elastic Stack as a whole. And that's definitely been the most valuable thing I've learned. I know so much about the Elasticsearch, maybe a little bit too much to be comfortable with, about Elasticsearch and watchers and stuff like that, because I've written this tool, because I've had to figure out how things work under the hood. So that's an amazing thing. And a quote, not everyone's going to get this, but I think it's pretty clever. Overall, building the CLI tool was a painful experience, but if it was painless, I would be a Java dev instead of a Golang dev. And I just came up with that. So future improvements, I'd like to add better documentation. The documentation is poor. In fact, this talk is the best documentation that this CLI tool has, and it shouldn't be that way, but that's the way it is. As I mentioned, the command structure is a little weird, so I have to figure out whether I want to go with the kubectl style or the Elasticsearch style. Every good product needs a logo. Mine doesn't have a logo, so it's not a good product by logical deduction. And I could leverage a little bit of code generation to make stuff a little bit easier. Right now, I have to write every function by hand, and that's nice when you have maybe 10 or 20 or even 50 functions, but as I'm trying to scale to maybe like 200 functions, which is probably what I'll end up implementing once this is complete, just mocking the API, I probably should invest in code generation which means I need to write better boilerplate. It's a vicious cycle. So those are a few of the things that I'd like to work on for this tool. But I think the documentation is a lot better than it used to be. A function of one of the packages I use, Cobra, is that the functions are almost self-documenting. The code itself and how to contribute isn't, but the functions kind of explain themselves to a certain degree. And the flags, the commands, and the other things that are exposed to various subcommands. So that's really neat, but that's definitely an improvement I need to make. And from you, the audience, I'd like you to use it. That's kind of the most important thing. And second to that is kind of file bugs and RFEs. I kind of want to know how you break it and what you want to see from it, and that'll definitely help the development efforts. I'm willing to do the work, but I need more users. So give it a shot. Maybe look over this demo again to see what I did, and so you can get started yourself. And there are a lot of options I couldn't talk about. Stuff like really cool tidbits, like if you specify, sometimes you don't want to put your password in config file, which is completely understandable. So what you can do is specify a name for a user, but not a password. You can have a password command. And what that password command does is it runs a command on your behalf and can use that to look up credentials, and it returns a string and uses that for the API call. Or if you completely don't define the password fields at all, it will prompt you. So that's a really cool thing you can use if you don't want to store your credentials in that config file. So there's a lot of options that exist. I just need to document them so people know they exist. So I went through a lot. Are there any questions? All right. I don't see anything. Nick and Faith, do you see any questions?
Question. Somebody's asking you to link to the Git repo.
Sorry about that. Let's see. I believe this was. I believe it was the second slide. Third. Here's a Git repo. I'll drop it in chat here once I figure out how to use Zoom.